Okay, so we spent the last set of notes talking about user-defined classes and then having specified methods for those classes. Now we're going to talk a little about making comparisons between objects that are specific classes and then also ordering those. So this may seem kind of strange at first, but it's going to get us a little bit more sophisticated knowledge about some of these functions, the double underscore functions within Python that are going to be useful here, and then also the use of these comparison operators in this kind of context. Okay, so let's go. We have set up a class of type thing, all right, and it has a few, here's the constructor, of course, here's the way that we stylize the output, and then we can run it on two objects. It's going to multiply them and then print it out using this stylized output double score string operator, or method, I should say. So, which is going to be the output? Should be a quick study of the code to figure this out. Given the input is 4, 5, I should say. Okay, so did you choose D? Take a look, see if you believe that's the correct answer. Come back and we'll talk about it in class, if not. So we're going to talk about, well, let me, this was just a review, by the way. So this is kind of reviewing stuff. And now we're going to talk about how we might use these classes that we define, such as the thing class, and be able to make comparisons or make orderings from them. So there generally in Python 6 relational operators. These are built in to Python. So we've used these before. Read through this if you want, but we've done this, so I'm not going to spend time on it. The default implementation for these kinds of operators on our own objects are sometimes not as useful. So for example, equal equal colon is same as is. The not equal, same as not is. We have some incomparable types here also, okay, with these like greater than or equal, colon. We can create some methods in Python that we can use for these kinds of comparisons that we want to use. Just like double score init, that constructor, we don't really call them directly. So for example, if we're going to make a comparison between P1 and P2 to see is P1 smaller than P2, but using some sort of constructor for understanding what we mean by smaller, we're actually calling this, okay? We're actually calling P1 our object, kind of our self. Remember, that's the self, with method underscore LT, double underscore LT, with the comparison of P2. So that's functionally what's happening. We just write it this way. I'm glad. This is a lot nicer. So let's add equality and not equal methods to the point class, that one that we've been using. Points are equal when it's equal in both points. And when the two x coordinates are equal, in other words, and the two y coordinates are equal. Okay, points are not equal in any other case. And so if we get a false back for the equality, double score equality operator or method, then we know that it's not equal. But we need to explicitly define each of these. So to kind of prompt ourselves to think about how to do this correctly, let's do a little test. on our cells. So we've got here a comparison operator. I'm going to pull my screen down a little bit. There we go. The class is account. Here we've got our constructor. It's going to set the value for, say, a amount of gold. Here's the value. There's the reference. And then we're defining the double underscore equal operator or method here. So we're going to return if self dot gold is if it's true that it's equal to 0, and other gold is 5. So notice other is an input, and then the self is, of course, the default. So which of these is going to evaluate as true? Here, take a moment and think about it. Okay, sorry, but okay. So evaluate this, take a moment. Think about what equality means here. It's not maybe the usual definition. Look at this return statement. So given this return statement, which is going to evaluate as true? Well, clearly not A or B. Let's wait for E for later. But look at C. Okay, that's the case where when we create an object of class account and that object has value 0, and the account here is tested for equality to another object of class account with value 5, we're going to get true here. But what about this one? What do you think? I keep popping out of full screen mode here. Sorry for that blip again. So what do you think about, where was I? D. Okay, well, the self and the other must be 0 and 5. So this should evaluate as false. So we really only have C, therefore E is not relevant. Okay, so think about that, test it out yourself, make sure you understand why C is the only one that evaluates to true here. Okay, so a little bit different setup, again, of class account, same constructor for that class, but now it just says when the self value is 0. So now which should evaluate to 0? Is it going to be more? Is it going to be more than the above? What do you think? Let's talk this one over in class, but go ahead and make a prediction before you run and see if you can really make sure this works out for you. Okay, so we can also add a less than method to the account class that returns a true if account has less gold than the other account. So for example, that value that we're talking about here that we've been evaluating here, if it's less in one account than another. That way we can make comparisons between the accounts. So we could go ahead and define less than and greater than, but that's kind of a lot of, less than or equal and greater than or equal, but that's a lot of duplication for kind of the same effect. And the reason we might want to do that, though, is because we don't really have that exact operator using these comparisons here that would make sense, okay? But why don't we just define only less than, and of course, we've already defined equal and not equal, and then just add total ordering above the class. Using this total ordering here adds everything that we would have, that we would need, like less than or equal, greater than or equal, for us to make comparisons. And that would be with just using less than and equal in a combination. So let's see what this looks like. What am I talking about here? Let's see what it looks like. Okay. So again, we've got our point. This gets back to the ordering of these slides. I could have improved, I think. Remember, let's see. Here, we wanted to go ahead and think about how we could add ordering to our point. So adding the equal and not equal to our point class took a little diversion looking at this account little concept test. So now we're going to finally do that. Okay. So here we've got the two-dimensional points. We construct it. There's our constructor. And then we're defining what is going to be less than. Okay. Okay. So we had our constructor. Here's our less than. What is this doing? Well, first, it's just ensuring that we have something stored in each of these constructed point class objects for the point, and using point class structure that is conformable to that what we defined here. So if this is not true, then none of the rest of this matters. That's why you logically want to, of course, lead with this, because it's going to evaluate this first. There's no sense in evaluating the rest of these if this is evaluated as false, because then we don't have a true instance of a point class object. Okay. So then let's take a look. If self is less than other in the x coordinate area. Okay, so this is a case that must be true. If x in self is bigger than other, then we don't have a less than case. So again, ordering is important here. Okay, and then the last part, by the way, this is just getting us to the next line. Then we have an or, because either this must be true, and this, or this must be true and this. Okay, so this or is in the right place again. We wouldn't want to say put this or this and this. This is the most efficient logical way to construct this Boolean evaluation. Okay, so the other way we could have less than is if the two x's are equal, but in the y dimension, self is smaller than other. Okay, so which of these would be evaluated as true? Weird. Well, anywhere where x's are less than or possibly equal. So that rules out C, right? We're not good on C. But A and B still look good. But what about this? Well, A still looks fine because Y is smaller in the self than on the other. But here Y is bigger. So what's going to happen here? Do you want to test it out and see? Take a moment and decide if you think both A and B are true or just A is true. I think it's pretty obvious A is true. Yeah, so on this one, you just going through the code here, we can really evaluate both A and B are going to be true. Stop and really make sure you understand the logic before moving on if that's not clear to you. Okay, so C clearly is not. So what if though, let me think. What if I change this to 1, 1? So option B, the second point here, would be 1, 1. Should be false then, right? Make sure you agree with that. If I made this one 1, it should be false. Okay, so now we've kind of figured out how we can make these kinds of comparisons. Oh, I'm nearly out of time. We'll pick back up later. This is actually the end of the notes too, so we'll move on from here.